Hi there, guys. So yeah, Viacom, Kubernetes, it's a real thing. Just in case you didn't know, what Viacom is. Viacom's a mass media company. And what does that mean? Well, we have cable companies or cable channels like MTV, Comedy Central, Nickelodeon, Spike, you name it, we might have it. Even if you're not watching it on TV, you might be watching it on things that we power. We also have a film company, we have Paramount, and we're not just domestic, we're also international. So there's a Comedy Central Poland, there's a Comedy Central in the UK, there's a MTV in India. So we have many different engineers writing many different things, everything from linear to supporting the linear channel to supporting direct to business, like say the Hulus and the Amazons of the world, and also direct to consumer, so your apps and stuff like that. What I'm mostly in charge of is doing websites and apps, specifically for music and entertainment. What you see right behind you is actually Comedy Central in various forms. There's Xbox, Roku, the website in Spanish, but on domestic, iOS and Android. They're each their own little special snowflake. They each have their own little feeds that they need. They're always a little bit different. And even within CC, or Comedy Central, it's a little bit different than MTV, because in MTV we care about music videos. In Comedy Central we care about stand-up. And in Nickelodeon, as you can imagine, they don't care about either one of those. So I think what isn't always discussed in a large enterprise is, and maybe Viacom's not as large as, say, Google or Amazon, but how you do containers. A long time ago, this was probably like what most sysadmins were. But if I needed to run hip-hop, by the way, we run hip-hop, we're a PHP shop in many ways. You have to go up to them at the right time with the right bribe, and you say, please, 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 give me hip-hop. And they look at you like, what the heck is hip-hop? How do I run that? How does that work on my environment? And so containers look very seductive. And so you start to play with them a lot more and more and more. And you come up with a plan. Just like Ferris. Ferris had a plan way back in the day. By the way, these are all Paramount films, so I can't get in trouble for this. This is all good. But you'll come up with a plan. You'll come up with a plan of like, hey, I'm going to create, as you guys probably have seen, I'm going to create an Apache container. I'm going to create an Apache image. I'm going to create an Nginx image. I'm going to create a Redis cluster. I'm going to map this all out. And I want to be able to share that. But then again, you also have some people who have no idea what they're being given, or maybe they do, and they take it out, just like in Ferris Bueller with the Ferrari. So what we found, and this is a little bit relevant, I think, is that you do need to have a process on containers. Back in the day when you had the Godfather and you had to ask for, please, please, please give me HHVM, there was a reason for that. Viacom, like I said, had one simple sysadmin team, and they had to deal with me. They had to deal with people in Poland. They had to deal with people in Italy. They had to deal with people from Nickelodeon. They all had different needs, and they all wanted crazy things. And they all needed to keep it all kind of working. You need to do this too with containers. You need to be able to share containers and share images. It's not just for rapid development, but it's also for things like compliance. So you don't want to have 4 different versions of Nginx, or maybe you do. Maybe there's a reason to have 4 different versions of Nginx, but unlikely. You may have an Apache 2.2, maybe an Apache 2.4. You might have pre-fork. Maybe you don't have pre-fork. But even then, you should only have one. It shouldn't be that the Poland people come up with their version of Apache and I come up with my version of Apache, that there's one version of Redis and there's another version of Redis. But containers let us do that. So what you need to do is you need to come up with like a system of saying, here's how we're going to support Docker images within our system. We're going to, just like there's a Docker hub where we can grab Redis and other images from other people that are contributing it, we want to have like within the company open source. That sounds kind of confusing, but think about it for a second. You have many different teams, and you want them to share code in a logical and rational way. So what we found is that you definitely need to put the Docker build stuff in a repository someplace, like whether or not that's CVS, I hope not, Subversion, GitHub, a stash, you name it, somewhere. Somewhere where people can do it, they can merge it, they can check it out, they can commit to it. And in that thing, it should be a little bit of documentation of how to use the image. Just because I created a CSS lint image doesn't mean that anybody knows how to use it. Sure, it's CSS lint, but what are the parameters to it? Are there environmental parameters? You need to document that out, and Docker build still doesn't really have a good format for it. I'm hoping someday they will, but right now they don't. And you should also have an image registry that it's local, or that's yours, that everybody's using. It shouldn't be that the people from, again, I'm picking on Poland people, but but the Poland people shouldn't be using Docker Hub, and the guys in the UK using Quay.io. You want to kind of, like there's maybe reasons for that, but you kind of want to have one stop for everything. You should always have an automated build. That may seem obvious, but not just an automated build is like it can build something, but something that actually verifies it. Maybe I did build HHVM, but now it doesn't actually run PHP because while it built, it doesn't actually run anything. And you should also have a maintenance plan. If I come up with a harebrained idea to come up with an image, like say Doxygen, then if I don't feel like maintaining it anymore, somebody else needs to be able to pick that up if they're going to be using it. And at the same time, if I'm maintaining it, somebody should be able to say, hey, dummy, there's a new version of Doxygen, we want to upgrade to it. Or hey, your version of Doxygen doesn't support this one plugin that I need to have supported. And you can create a Jira queue of it. Maybe I say, I don't have time for that. But that's okay. Jira, it doesn't have to be Jira, but you get the idea. Just peddling different software programs. But you get the idea. You need to have that, because what we found was that when we just said, here's a Docker registry, have fun. People did have fun. And there was at least like 5 different, I can tell you that there's 3 different composer update Docker images. None of the 3 work the same, and I have no idea why there's 3. But there really should only be 1. And composer is a PHP thing, but don't worry about that. So anyway, so yeah, you want automated builds. It looks beautiful. Everyone's happy about that. So that's just a little bit about that. But where do we use Kubernetes? I mean, you guys you came here for Kubernetes. I assume you want to know why we're using Kubernetes or where we're using Kubernetes. And the answer is in many different places, at least right now. We use it for continuous integration. We use it for demo sites. And we've actually tested some live sites on it. When I say continuous integration, continuous deployment, I don't mean just the fact that you can do a rolling update with Kubernetes. That's great. What I mean is that you can actually stand up a testing site, run your tests against it with the CI/CD server, and then tear it down. You can do that with Amazon or Google Cloud. You can do it all. But it's really easy and natural within Kubernetes. You don't really need to have a dev or QA server running 24 hours, 7 days a week when you're not building against it. So, even though they're services and services should last forever, they don't really have to last forever. We also use demo sites. As you can imagine, we have a large library of software. And you can imagine that CC Poland, and again, I keep on going back to Poland, sorry. But you could imagine that CC UK and CC America are very similar in some ways. They're a little bit different, but somewhat similar. They have different tech teams, but they're somewhat similar. We want to be able to share code. We want to be able to share code from Comedy Central to Spike, to MTV, to Nickelodeon. And so therefore we have feature libraries. This is more of a software development idea, but you have feature libraries. But you need to demo them. You need to be able to take to somebody, you need to show somebody, here's how it works, here's a white label version of it, here's how it works. And anytime you do a change to that library, you want to have it rebuild, retest, and redeploy to that white label. This works really well with Kubernetes. Kubernetes, normally we would have to have a very large we'd have to create a VM pool for every single demo site. We'd have to, have it monitored and everything else. And you still need that, but it's much easier if I just come up with a library. I have the ability to just create a service as I need, and I can give it very limited resources. I mean, in Kubernetes nowadays, you can give it like guaranteed CPU and memory, or you can give it burstable CPU and memory, because in all likelihood, these demo sites are not being run very often. And so, again, this gets back to the idea that a developer can have self-determination. Just like they can create their own images as they need, they can create their own services that they need. And we have actually run full-fledged websites. We reverted them very quickly. That's not because they went down. They actually were fine. But we found that operationally we weren't ready yet. While I may be comfortable running Kubernetes scripts, and while my team may be comfortable with it, that doesn't mean that everyone down the line is very comfortable with this idea. It's just true. We found that there is a lot of culture shock. Viacom is a company that used to run on bare metal in Secaucus, and we're moving to Amazon. And in many ways, it's just moving what was in Secaucus into Amazon. What was a VM, or what was a bare metal machine is now a VM. That was a little bit of, that was a little stressful for a lot of people. They didn't know how everything worked. To move to containers, stresses them even more. And then to move to Kubernetes is like change fatigue. People really have, they're just like, this is crazy stuff. You're creating a VM within a VM. And that's not really true, but it is true. You do suffer a lot of change fatigue. You do suffer a lot of people who are very concerned and very confused. And they come in with systems that are great at monitoring VMs, but not great at monitoring containers. Because if you were to imagine a Kubernetes cluster that has maybe 20 nodes and it's running 100 services, it's very hard to be able to track that the traffic that's coming from this machine to that machine is legitimate traffic. It's not like one machine trying to attack another machine. As you can imagine, when you have many websites, one of them could be compromised, and you don't want to. You want to feel secure that if one service is compromised, that it can't easily attack another service, and you want to be able to audit that, just from a compliance point of view. So if you're going to go through a Kubernetes migration or even a container migration, be prepared to go through a lot of emotional states. Again, we own this, so I can use this, but but you will have joy, you will have face palms, you'll even be playing that musical instrument. The dance to Kubernetes is a long dance, but it's a well worth dance. So yeah, good times. So you guys probably have heard of other companies that have been doing that sort of thing. So what are we doing right now? Well, right now we're actually going to do a phased rollout of actually moving for realsies, most of multi-platform and maybe even more to Kubernetes. The first step was to just create a production environment. You guys may be concerned about this. What is a production environment to us? It means a multi-availability zone system. Kubernetes will clearly state that they don't support multiple availability zones. That's true. But if you're within like Amazon and you're within one availability zone to another availability zone for a region, and you're running mtv.com, it can handle it. It's not that bad. If you're doing stock transactions, maybe not. But it works for us. It works pretty good. etc does pretty good for it. Kubernetes, it works pretty well. You guys may have heard of the Ubernettie project. The Ubernettie project is great. It's also not there yet. So when Ubernettie is there, we'll move to it, and it's great, but we don't have it right now, so we're not going to worry about it right now. Just like I mentioned earlier, monitoring tools are very important. I mentioned sysdig in this slide deck. It doesn't have to be sysdig. It can be other things too, but you do want to make people feel comfortable when they move to containers. They're going to be used to things like, I don't know, Splunk or Sumo Logic or whatever it is for log aggregation. And what's the new log aggregation inside of containers? They may be used to monitoring intrusion detection between one machine and another machine. And how are you going to solve that over there? How are you going to be able to graph it right there? You may be interested in service monitoring, like Prometheus, for example. Prometheus is a really good service monitor, and it has a lot of things off the shelf, and it works well with containers. And of course, you'll have to figure autoscalers. But once you do that, then you need to probably have like an MVP candidate, a minimal viable product. Our minimal viable product is mtv.com. We don't want to, we're not going to just dance it with a little small site or a small site in Ireland instead of Poland. We want to give it a real site. We're going to give it MTV. And it's not that hard. I mean, MTV has been run on Kubernetes for a night, and it worked out just fine. But we have a lot of faith in containers, and we have a lot of faith in Kubernetes. And we also feel, or at least I feel, that you're more likely to find bugs if you actually have a lot of eyes on it. I know that sounds terrible, but it's true. If MTV goes down for 10 minutes or 15 minutes, maybe somebody can't watch 18 and Pregnant or something for 5 minutes. That's okay. I'm willing to take that chance. I'm not going to do it for the VMAs, but I will do it for Eye Candy or Teen Wolf or it's okay. I mean, people, they'll yell, they'll scream, but it'll come back up. I always like it when it goes down and nobody notices. You're like, did anybody pay attention? When I first worked at Viacom, we took down Colbert's website, and I thought I was going to get fired, and everyone went, what? It happens. I was like, wow, this is a company for me. They tolerate failure. Then later I found that they only tolerate so much, But no, if you have something like a 12-factor app, a 12-factor compliant application, Kubernetes is a perfect match for you. Even if you don't have 12-factor app and you do have things that use persistent storage, Kubernetes is still a good choice, but it may be something that's a little bit harder for you to get running the first time, the right time, right away. And that's not saying that Kubernetes can't do it. It can do it pretty well. You probably don't want to make your first site something that uses persistent storage. So yeah, mtv.com is there. We'll probably roll it out to multi-platform. Whoa, oh, it's back. So we'll probably move it more to multi-platform. When I say multi-platform, for me, that means like consumer-facing websites and apps. It's not going to be like things like linear. It's not going to be things like bulk media encodes for Hulu. It's consumer-facing content or consumer-facing products. But if we're going to be moving to multi-platform, you're going to have to solve access control. Right now, if you run Kubernetes, if you have in the past, as long as you have the root, or as long as you have SSH access to the Kubernetes master, you're pretty much good to go. You can do whatever you want, however you want, whenever you want. And that may not be the right answer. Is it flickering for anyone? Not just for me. Okay. No, really, there's a screen down here and it flickers every now and then. Oh, okay. Then at least it's consistent, right? It's a feature. What?
Eventually.
Yeah, eventually consistent is a very good thing. So anyway, so what you need to do is you need to solve access control. You got to make it so that, I pick on the people in Poland in my slide deck here, but you got to make sure that Comedy Central Poland developers, I'm really not doing any, I didn't even touch it. I don't. Anyway, they should not be able to modify ComedyCentral.com's like settings. They shouldn't be able to scale up ComedyCentral.com. They shouldn't be able to get the Docker secrets for ComedyCentral.com. They live in their own world. And so what you're probably going to have to do is you're going to implement some sort of access control. Kubernetes is working on that. It's not there yet. So if you want to do this today, you got to write your own intermediary. Your own intermediary can just be an endpoint that validates, hey, I'm so-and-so. You have access to this namespace, you can do this, or you don't have access to this namespace, you can't do this. Products like Tectonic, they have that kind of out of the box, and that may be helpful. It's up to you. But yeah, so the other thing that would probably is very useful if you're going to really be rolling this out into the large enterprise is Ubernettie, which is not out yet, but just, you guys are planning now, Ubernettie will be out later. And if you're doing multinational stuff, things like European Data Federation needs to be respected. You need to have European content being served in European servers. And you want to be able to kind of deploy your code independent of all that. So, you will start to care about having multiple regions and having one giant cluster. But right now, you can just create separate Kubernetes clusters and not worry about it. In fact, maybe you never care about it. You just say, let's spin a new cluster up. But long term, what we want to do is we want to use this for the entire Viacom infrastructure. We want to make it so that not just linear, not just multi-platform, but even things like corporate email is hosted on, containers and inside of Kubernetes. It makes sense. We get the most density from that. We get we get a consistent environment. We don't have to worry about corporate being one way and multi-platform being another. But that will probably be a much longer case. You see, as you can imagine, as you play more and more with Docker, you're going to get a lot of people who are very concerned about where the traffic is going and where the traffic is coming. And if you're storing corporate data, you may not want to have that on those other services. But that shouldn't scare you away from Kubernetes. It shouldn't scare you away from containers either. It's just, at times you may have to create separate clusters until we get better at this. So that's about it. Any questions?
So how big do you need a Kubernetes cluster to scale before you think you can take over the world?
I would, something like Viacom is over 1,000 VMs, so you would probably, like Viacom in general, would be over 1,000 VMs. And probably you want to be able to expand elastically. Like if we suddenly sell, a volume of Paramount videos to Amazon, and Amazon wants it in certain formats, we may want to very quickly expand out our video encodes and then contract back to the normal usage. So, that's where things like Kubernetes could become very useful because it can, go from our current data center to another data center. And also, it also lets you play one cloud provider against another cloud provider. I hope no cloud providers are here. But seriously, I mean, if you have something like Kubernetes up and running, you don't really necessarily care if you're running on Amazon or if you're running on Google or if you're running on DigitalOcean. You care about whoever's giving you the best service. We do that with Akamai versus Level 3 versus Limelight, I think it is, or LimeWire. One is a CDN, the other one is not a CDN. And I always get them confused. They both start with Lime, it's their fault. Any other questions? What's up?
So you mentioned it's good to have a process. In fact, it's necessary to have a process around the entire build idea. What do developers get to touch? What do they get to add? So yeah, I guess you have an internal registry, but you go further and try to do some enforcement along the lines of thou shalt only use these particular base images, thou shalt not do these kind of things in your container.
We want to strongly encourage you to use a certain set. I'm not sure if you guys have ever heard of Alpine. It doesn't always work within Kubernetes super well, but Alpine Linux is a really good base image to base a lot of things off of. You can get really small images. We would like that. We would like it so that your CSS lint is running off of Alpine, and that way it's easier for us to audit if there's any security risks. But we don't want to become the Godfather again. We don't want to say, you have to get this working with this base image. Otherwise, we don't support you. Like Viacom currently runs on VMs or on CentOS 6. Again, I mentioned hip hop a lot. Hip hop is a pain in the butt to get working on CentOS 6. It works really well on Debian. It works really well in Ubuntu. We have no problems running MTV.com on hip hop on Ubuntu, but we have a lot of problems running MTV.com with production load on CentOS 6. So, we want to avoid that situation. But yeah, you're right. You should have a process and it should be flagged, right? The exceptions should be made. But, you want to strongly encourage reuse. It's not just reuse for auditing, but also reuse for rapid development. If I come up with a really good pod definition of how to create an auto mirroring MySQL master setup, then everyone else in the company probably would want to use it if they're going to want to use MySQL. Again, it gets back to that whole idea of internal open source or intra-source, whatever you want to call it. Any other questions? All right.